Okay, thank you. Okay, so just let's do the recap for yesterday. What we did. Anything you feel that we need to revise, we need not understood, or anything need to be discussed again. Any points? Anything you have not understood, or you still need some refresher on that part? So yesterday we did about the stakeholders and drone rules 2021, and then we talked about the basic principles of flight. Then we talked ATC procedures. Then we had a topic on fixed wing aerodynamics and operations, and then we have rotorcraft aerodynamics and operations activity. Okay, from yesterday's session, we need to complete hybrid operations and aerodynamics. As I told you yesterday evening, that we'll taking that module in the beginning today, which was left from the yesterday's session. Okay, that's a small presentation which will take off. It is basically the revision of your fixed wing and the rotorcraft. So hybrid is nothing but it's the in continuation with your fixed wing and the rotorcraft. Okay. Let me know once you are able to see the screen.
Yes, sir, we can see it.
Okay. Okay, so hybrid operations and aerodynamics. So when we talk about hybrid means it's a combination of aeroplane and the rotorcraft model. Okay, so aeroplane means basically it will have a wings aerodynamically designed, a fuselage, the wings, and then it will have the primary control structures. Can you somebody tell me what are the primary control structures of aeroplane? Any idea? We discussed about this primary control structures or controls.
Rudder,
Okay, sorry, come again. Brian,
rudder,
rudder.
elevators,
Correct.
uh,
Ailerons.
Ailerons. So wings, you will have ailerons. On horizontal stabilizer, you have elevators. On vertical stabilizer, you will have rudder. Okay. So on tail section, you
Flaps.
have horizontal stabilizers as well as vertical stabilizers. On the wings, you will have ailerons. Okay. So wings, ailerons will control your roll movement. Correct. Ailerons will control your roll movements. Rudder, which is on the vertical stabilizer, will control your yaw movements. When you say yaw movement means what will happen actually? When you say yaw right or yaw left, what actually happens?
Changes the
Turn.
direction.
Change of the direction. Very good. So basically, you are changing the heading of the aeroplane or maybe drone also. So when we are flying the drone, we'll normally I would say, okay, your right, your left, your right 90 degree. So you have to change completely the direction of your drone from whatever it is heading. If it is heading straight, it has to completely change to 90 degree. Okay, that is what you need to do. Again, I would might say, okay, go pitch forward. So you may have to, by after 90 degree, you go forward. Again, you say right, you're right, 90 degree. So again, you have to change it like this. So that way you will completely complete one square of the flying of your drone. So when you are flying a drone during the practical sessions, you will be given a circuit. Like you may go triangle, you may take a rectangle, or you may make a right angle triangle. All that kind of thing. So different. You might have to create a right side square, left side square, right side triangle, right left side triangle. All those things patterns we will be creating. Before that, we will be practicing on the simulator. When we tomorrow, the same time when we meet at the resort, we will be beginning initially with the summary sheet revision, and then followed by post lunch we will be doing our simulator session. So we'll be sitting on simulators, and you will be flying the drones on simulators and creating the patterns over there, learning all the basics what is required for actual drone to fly. Okay, so this controls yaw is actually your change of heading. And then by elevators, what we are trying to do, elevators is on the horizontal stabilizer. So by changing the elevator, what will happen in aeroplane? I'm talking about in aeroplane. What will happen in elevators?
Elevator pitch on the plane up down.
Correct. So elevator will control the pitch movement of the aeroplane. Either it will be pitch up or pitch down. Okay,
Down.
based on the controls. Now you see there are no control structures on the drones. So then how does the drone controls all this, or how does the drone is able to maneuver all these things, like yaw kar sakta hai, roll kar sakta hai, pitch kar sakta hai, throttle kar sakta hai. So how these things happens in drones? You do not have any control surface as such. कि ड्रोन में कहीं रडार नहीं है, ड्रोन में कहीं एरोलॉन्स नहीं है, ड्रोन में कहीं पे भी एलिवेटर्स नहीं है. So how does drone control does all these functions what a aeroplane is able to do? How are we able to achieve these features into the drone? Any idea? What happens when, let's say, take an example, pitch forward. So pitch forward, when we say pitch forward, we are giving a push to our stick, okay, right stick. तो क्या हो रहा है तभी, क्या होता है एक्चुअली? हाउ डज द ड्रोन मेक्स दैट मूवमेंट? पिच फॉरवर्ड कैसे होता है, क्या होता है एक्चुअली? एनी आइडिया? हैव यू थॉट अबाउट इट?
Up front, CW and CCW motor increase the power, and back motor lose the power. आगे की मोटर ज़्यादा पावर से घूमती है तो फॉरवर्ड डायरेक्शन में जाता है, और पीछे की मोटर पावर कम करती है, मतलब स्लो घूमती है. मतलब फ्लाइट कंट्रोलर पे डिपेंड, वो फ्लाइट कंट्रोलर उनको
सर एक्चुअली ऑपोजिट होता है, उल्टा होता है.
करेक्ट, करेक्ट. सो उमेश, एक्चुअली व्हाट यू टोल्ड इज रिवर्स ऑफ इट. फ्रंट मोटर्स जो है आपकी स्लो हो जाती है, और पीछे की दो मोटर्स है वो फास्ट होती है. तो अगर आप देखा रहेगा, ड्रोन ऐसे स्ट्रेट है, हॉवर हो रहा है. जब आप थ्रॉटल देते हो तो क्या होता है, सॉरी थ्रॉटल में पिच देते हो तो क्या देते हो, वो थोड़ा सा टिल्ट हो जाता है. यानी कि क्या होता है, आगे की मोटर थोड़ी स्लो हो जाती है और पीछे की मोटर ज्यादा फास्ट घूमती है, तो वो एंगल क्रिएट होता है. तो पीछे से थोड़ा सा ऊपर आ जाता है ड्रोन, और वो ऐसे मूवमेंट हो जाता है. ओके, सिमिलरली पिच बैक करते तो क्या हो गया, आगे की मोटर फास्ट घूमेगी, पीछे की स्लो हो जाएगी और पीछे आएगा. एंड द सेम थिंग आर एप्लीकेबल फॉर रोल मोशंस. रोल भी मतलब क्या है, रोल इज नथिंग बट इट इज एक्चुअली पिच लेफ्ट एंड पिच राइट ही होता है वो एक्चुअली, देखा जाए तो. ओके, देयर इज नथिंग लाइक ऐसा पूरा टर्न नहीं करता है ड्रोन आपका. ओके, अगर आप ज्यादा रोल करोगे तो बात अलग है, बट वो रोल में क्या होता है, आप जब रोल लेफ्ट देते हो या रोल राइट बोलते हो तो क्या होता है, वो एक्चुअली पिच लेफ्ट या पिच राइट ही होता है. जो पिच मूवमेंट्स जो है आपके ड्रोन के अंदर, वो सिर्फ रोल में दिखा, बोलने के लिए हम लोग रोल बोलते हैं, बट इट इज एक्चुअली अ पिच राइट एंड पिच लेफ्ट ही. ओके, दीज आर द थ्रू मोशन. फिर आप देखो इसमें क्या होता है, जब आपका यॉ मोशन होता है तो क्या होता है, देयर आर ऑपोजिट डायरेक्शन मोटर्स आर एक्चुअली मूविंग. ओके, सो वो उसके हिसाब से वो टर्न मारता है. ओके, दैट इज हाउ द कंट्रोल इज देन ऑन द लेफ्ट एंड द राइट साइड. थ्रॉटल में क्या होता है, आपके चारों मोटर पुश करते हैं एक साथ, तो इसीलिए आपका एक साथ हॉवर में आपका एक साथ ऐसे ऊपर जाएगा, या थ्रॉटल डाउन करोगे तो एक साथ नीचे आएगा. ओके, पैरेलली. So these are how motion. So you have to observe this when, see, as a drone pilot, your job is more about observing also and understanding the motions, how things are happening, what is causing the motion, what is causing left, right, all these movements, what happens, you have to observe. So when the pilot is flying, the job of the co-pilot is to make sure that whatever the task is being performed by his partner pilot, he is actually helping him or guiding him to do the things properly. Okay, for example, there are some certain points which you need to verify before actually flying the drone also. That point in time, the co-pilot का काम यही होता है कि पायलट जो काम कर रहा है या वट एवर एक्शन ही इज, बिकॉज ही इज इन कमांड इन पायलट, पायलट इन कमांड, तो वो पायलट इन कमांड इज डूइंग थिंग्स प्रॉपरली और नॉट, एंड यू हैव टू करेक्ट हिम और यू हैव टू गाइड हिम saying that this is what is required, this is what is required, this is what required, and vice versa. जब co-pilot पायलट बन जाता है या पायलट इन कमांड बन जाता है, the other person who becomes the co-pilot, his job is also to make sure that he is helping his teammate to do things properly. So when you are flying the drone, you are flying as a team. Okay, similarly when you are flying an aeroplane, you are flying it as a team. Even in remote drone operations जो होते हैं, उसमें भी आप देखोगे, if I am sitting somewhere in a knock, okay, or a control center, वहां पे भी दो लोग बैठे हुए रहते हैं. एक बंदा रहता है वो पूरा मैप मॉनिटर करता रहता है कि आपका ड्रोन सही से सही पाथ पे फ्लाई हो रहा है नहीं हो रहा है, उसके कंट्रोल्स देखता रहता है, बैटरी कितना चल रहा है या पावर जो भी पावर फ्यूल जो है वो फ्यूल कितना कैपेसिटी है, उसके बाकी के स्टैटिस्टिक्स जो सेंसर्स डिटेल्स देते रहते हैं, एल्टीट्यूड है, लैटिट्यूड है, लॉन्जिट्यूड है, टेम्परेचर है, all that parameters are being monitored by the co-pilot. Pilot job is only to fly as per the requirement. Okay, so his job is to only fly and make sure that he's in complete control of the drones. But the secondary parameters or secondary points जो है, जैसे कि path है या फिर आपका altitude है, longitude है, latitude है, temperature है, wind speed जो भी आ रहा है वो टाइम पे, whatever it is there, all these parameters are being monitored by the co-pilot. So same thing when we are actually flying the drone, the co-pilot job is the same thing. He is actually making sure his pilot is flying the drone properly as per the requirement. Clear? So let's move ahead with the hybrid operations and aerodynamics. So as per our aeroplane operations and aerodynamics, and similar to our rotorcraft operation aerodynamics, the combination of both is hybrid. Okay, so let's see the table of content, principles of aerodynamics, types of hybrid drones and parts, and then what are the applications of hybrid UAVs. So again, as per, since the hybrid drone also or hybrid craft also will require the force acting on the drone, because it is also having the similar structure to the aeroplane. So the lift will be there, weight will be there, thrust will be there, drag will be there. So airflow changes pressure distribution over the airfoil. So when it is in flying in a front forward motion, normally it is flying, the hybrid drone is actually flying like a aeroplane. Okay, so we saw about the aerofoil yesterday. Aeroplane is nothing but it's a cross section of the wing. Okay, it has a leading edge, then it has a trailing edge. The straight line from leading edge to the trailing edge is called as chord line, and there is another line from leading edge to trailing edge with making sure the distance from the top surface and the bottom surface is equal at any given point in time. आप यहाँ पे भी मेजर करोगे तो ये डिस्टेंस और ये डिस्टेंस सेम रहेगा. If you measure distance over here also, this distance, this line is called as camber line. Okay, so there are two lines what we call. One is the chord line. Chord line is always straight line from the leading edge to trailing edge, whereas the camber line is the line from leading edge to trailing edge, keeping the distance from upper surface and the lower surface same. Okay, and the distance between the leading edge and the trailing edge is called as chord. Okay, the distance between the leading edge and the trailing edge is called chord. Okay, so again the terminology: leading edge is the part of the aerofoil hits the air particle first, trailing edge is the part aerofoil hits the particle last, chord line is a straight line joining the leading and trailing edge of the airfoil, chord is the distance between leading edge and trailing edge, lower surface is the surface on the airfoil between leading and trailing edge on the lower surface, upper surface. Mean camber line is the line joining the leading edge and trailing edge of a airfoil equidistant from the upper and the lower surface. Okay, this is what I told. Equidistance. Okay, this is the word, equidistance from the upper surface and the lower surface. Okay, so maximum camber is the maximum distance mean camber line from the chord line. So camber line का maximum distance कहाँ पे होगा? Somewhere here where the surface distance is more. Curve surface जहाँ पे ज़्यादा है वहाँ पे आपका camber line का distance ज़्यादा होगा या maximum camber line होगा वहाँ पे. Okay, और maximum thickness also. What are the forces acting on the hybrid drone? Since hybrid drone is similar to your aeroplane, the lift is the force that holds the drone in air. The wings create most of the lift used by the aeroplane. So when actually the hybrid drone में क्या होता है? Normally it cannot take off on the runway. It is configured in a such a way that it can take off from the particular location itself or the same location itself. That's why it is also called as VTOL, vertical takeoff and landing. So here your hybrid drone is not actually running on the runway, but it will vertically take off. Then it will do a transition and convert itself into a aeroplane mode. In during the aeroplane mode, when it is in a forward motion, wing creates most of the lift used by the aeroplane. Weight is nothing but weight of the force caused by the gravity. So जो भी आपका एरोप्लेन है, ओके, उसका वेट तो रहेगा, वॉट एवर द मोटर है, बॉडी है, फ्यूजलाज है, landing gear hai, whatever is all those things will cause the weight of the body, and that what weight will cause the gravity to pull the aircraft down. Thrust is the force that moves aircraft in the direction of the motion. जो भी आपका motion of direction रहेगा depending upon your propeller, okay, front loaded propeller रहेगा या back loaded propeller रहेगा, depending on that it will create. The propeller can be powered by using jet engine, rocket, or maybe even BLDC motors also. So air is pulled in and then pushed out in opposite direction. One example is like household fan. Drag is the force that acts opposite to the direction of the motion. It tends to slow an object. So yesterday also I told you, like normally any device which actually even if you are driving a car will also have a drag on it, affecting on it. That's why car will try to slow down when we are driving it. Okay, drag is caused by friction and the difference in the air pressure. An example, putting your hand out of a moving car window and feeling it pull back. So yesterday I told you, like if you take the hand outside your car window and you are parallel to the ground, you can feel the air, but you just tilt it, your hand will try to go up. But if you try to pull more, okay, it will go back. Okay, so that is a drag. So now it is not helping you to fly, but it will drag. Drag means it will create a force opposite to the motion, and it will try to go back or pull down that device or that aircraft. Okay, so there are the four forces: lift, weight, thrust, and drag. So again, the same yesterday what we discussed about airflow and pressure distribution over the airfoil. The longer path or the equal transit theory, what it is also called for the Bernoulli principle. The difference in the pressure produces the lift. How the difference is there? On the top, the air is flowing at a high velocity. That means there will be a low pressure. Whereas the air below the surface is flying with a low velocity. So high pressure is created. And this difference causes the lift. And that's how your wing is lifted in the air. Okay, so now let's see what are the parts of hybrid drones. There are totally 4 plus 1, 5 motors. Normally we call it as 4 plus 1 configuration. So you will see there are 4 motors or a quadcopter kind of thing which will help a hybrid drone to vertically take off and vertically land also. And there is a 5th motor which is called as a pusher motor. Now here the 5th motor is connected at the tail section or backside of the fuselage. That's why it is called pusher motor. If the same motor would have put up here in the front on the nose, it would be called as puller motor. Okay, so depending upon the position of the motor, we call it as either it is a pusher motor or a puller motor. So you can see here in a part of hybrid drones, there are 4 motors which are called as the lifting motors, and then you have a structure like aeroplane with wings, with ailerons. Then you have vertical and horizontal stabilizer. So horizontal stabilizer will have elevators, whereas the vertical stabilizer will have radars. Okay, so this is how the configuration happens. So normally if you see there are types of drones, hybrid drones configured in such a way the same motor can be also used for both purposes. Okay, not only for vertical takeoff, but after vertical takeoff it will transition the maneuver, the motor will get tilted. So when during the takeoff they will be pointing upward direction. But when the transition is maneuver is done into horizontal flight, the motor will be parallel to the ground and it will be giving a thrust in a forward direction. Then when it comes for again landing portion, again there will be a transition maneuver will happen. The motor will again change from horizontal to the vertical direction, and then vertical landing will happen for that particular hybrid drone. Okay, so that is how actually your hybrid drone will function. So there are different types of configuration with 4 motors or 5 motors would be there. Sometimes even some drones are configured in such a way there are only 2 motors. So those motors actually transition the aircraft from vertical takeoff to a horizontal movement. So best drone for that kind of it is by name Wingtra. Okay, you can see this orange. Okay, this is one of the best hybrid drone which is being used extensively for surveillance purposes. This drone currently version is version 2. Okay, whatever you are seeing the picture here is this is version 1. Version 2 has a high quality payloads like lidar and thermal and RGB. All sorts of cameras are there in the fuselage. So normally this drone will vertically take off and then it will transition as an aeroplane when it is in air. Okay, so you can see another set of drone also here where your motors will transition from horizontal to the vertical positions. This drone we have already seen where we have total 4+1, that is 5 motor configuration. So your fifth motor is basically the pusher motor, and the remaining 4 motors are like a quadcopter, or it's like basically a lifting motor. So any questions on hybrid drones? So actually, this type of a drone, I am already engaged with one of the organization in Rajasthan, where I am giving my type certification consultancy services to them, where they are actually developing this type of a drone, because they want a surveillance drone to be made over the border area, so that it can be flying and can be taking the pictures of the border area for surveillance and inspection on the border part of the Rajasthan. So we are actually designing, almost we have designed this type of a drone. Currently, we are working on getting the prototype developed, and then probably we'll go for a testing. And so currently, the design part, I mean, we are not able to reduce the battery weight because we want to keep the battery weight minimal and get the minimum 30 to 40 minutes of flight time for that drone. Whatever the currently batteries what we are having, we are getting only 20-25 minutes of flight time. So we want to increase that to somewhere around 30 to 40 minutes of flight time. So we'll have a considerable flight time when we are flying this type of a drone. Yeah. Any questions on hybrid drone so far?
No.
Okay, so let's see now what are the application where we actually use hybrid drones, because we have already aeroplane, we have already a rotorcraft. So what is why there is a requirement of combination of the two? Okay, why we have designed a third type of configuration, that is a hybrid drone. The hybrid VTOL is used in operation where terrain is difficult to land a fixed wing airplane, but endurance need to be more than a multi-rotor. So, you are trying to take the advantage or the best part of both options. Like aeroplane ka advantage kya hai? Endurance is high. But aeroplane ka limitations kya hai? Ki it needs a landing strip. So, by using the best of the both, fixed wing aeroplane and the multi-rotor ka, best features you are utilizing and making sure that you are getting the best out of the both. Okay, so you are using a fixed wing configuration so that you get more endurance, whereas you are getting a multi-rotor configuration so that you can take off from anywhere. Okay, you don't need a landing or takeoff strip, and you can hover that also on a particular area. So best दोनों चीजों का जो pros है, okay, that options you are considering, and you have built a hybrid VTOL. Okay, where this is actually used, hybrid VTOLs are used for large area mapping. Okay, like as I gave you example that I am already engaged with one of the company where they are developing it for monitoring the border area. So large area mapping or monitoring a large area. Okay, it is also used to transport heavy payloads over a large distance with hilly terrains. जैसे आसाम में है, केरला में है, where you see most of the locations they are not plain locations over there. Like अगर आप आसाम गए हो या केरला जाओगे तो you will not see a plain areas like how we have in Maharashtra, Madhya Pradesh, Karnataka. You know, this there you will see a lot of land which is very very flat. But as you go near to the Kerala or you go to Assam location, all those locations are very hilly locations or terrain kind of. So you will always have a slope structure over there. So you will not see most of the land flat land or like that. So in those area, hybrid VTOL will work very effectively. Okay, so that you don't need to worry about where to land and how to land, because because of the aeroplane structure and all that things. Also, this type of drones are used in search and rescue as well as cargo deliveries, depending upon the requirement. तो मोस्टली सर्च एंड रेस्क्यू में भी यूज होता है, कार्गो डिलीवरी में भी होता है, इवन फॉरेस्ट में अगर आपको सर्वेलेंस करना है तो वहां पे भी आप हाइब्रिड वीटॉल यूज कर सकते हैं. Okay, sometimes in Africa kind of jungle which are spread over kilometers, not about acres, but we are talking about kilometers of jungle. That location will always utilize hybrid VTOL so that we get a very good endurance capacity. And whenever we particularly, like let's say मैं fly कर रहा हूँ और I don't know, I'm searching for let's say zebras, okay, in that forest area. I may just go on. Once I reach the what we say, the all zebras everywhere, then I can hover at that particular location, take as much as pictures I want, and then I can move forward. Okay, like that. So that is what is the advantage of hybrid VTOL. I can always transition like an aeroplane. I can transition as a multi-rotor also, as on when required. Okay. So if I'm flying a normal aeroplane kind of configuration, it will continuously move forward. It will not hold or it will not stop at that particular location. I cannot transition it. Or if I send a multi-rotor has limitation of flight time. So it can only fly for 10 to 20 minutes, 30 minutes max, not more than that. So I'm losing that. So every time I have to send drone with again a new battery, again I have to do it. So it will be not a feasible solution for me. So in this scenario, when I need a more endurance and I need to take off the drones from vertically, in that scenario I will use hybrid VTOLs. Okay, so with that we complete the module on the hybrid aerodynamics and operations. So any questions we have on hybrid operations and aerodynamics?
No.
So now we'll start the topic weather and meteorology. So when we talk about weather and meteorology, what does comes to your mind? How weather will be impacting the drone operations?